Hello, further to my previous videos covering the installation of an air source heat pump in a brand new house, the content of this video will mainly be about an issue that's occurred during the initial testing of the heat pump. Firstly, I'd like to thank everybody who commented on the need for a low loss header on this installation. As you can see from this video, I'm conducting a low loss header removal procedure. The low loss header seemed to be superfluous, so I've replaced it with just straight through pipe work. As a few people pointed out, the buffer tank itself is a low loss header, so to have an additional one was just adding complication to the system. Having said that, I've not really noticed any difference in the performance of the system since removing the low loss header. However, as you will see shortly, the superfluous low loss header is the least of my problems on this installation. Basically, the heat pump that I've installed, due to poor air circulation, depending on the air temperature, the surrounding air temperature, it becomes a block of ice after approximately half an hour. When the sensors on the heat pump detect that it is frozen, it then goes into defrost mode. Basically, when the heat pump shuts down and goes into defrost mode, it goes into reverse, if you like, and starts extracting heat from the pipework and the heating system to melt the ice that's formed on the condenser. This means that the heat pump will just keep cycling every half hour, which is not very good for efficiency. In fact, this heat pump has been running at a COP of 2.5, which is terrible, so something's got to be done. Here you can see I've set up 3 thermometers in various positions on the heat pump. I've done this so that I can get a good understanding of what's going on. The streamer that I've attached to the front grille of the heat pump gives a good visual reference as to when the heat pump is actually running. What you can see here is the air temperature and humidity before I start the test. So this is the heat pump after half an hour. It switches off and goes into defrost mode. So while this is going on, it's sucking heat out of the heating system, and also the house is not being heated. I've got to say, despite this, the target temperatures are still being reached within the house, albeit a little less efficiently than we would like and a little bit more expensively than we would prefer. So this defrost cycle takes between 5 and 10 minutes depending on the temperature, and then it takes the heat pump about 5 minutes to start ramping up to max output. So already at this low level thermometer, I can see the temperature's 2 or 3 degrees below the normal ambient temperature. Here I can see that the temperature's slightly lower on top of the heat pump, and out the front of the heat pump it's about 8 degrees. So the heat pump is starting to ramp up now. If you haven't already, I wonder if you would consider subscribing. It is free and it helps give incentive to create more content. Thank you. You can see the top temperature is about 7.5. This one's dropped about to 4.6, and that's 1.9. For your convenience, I've speeded the video up a little bit so that we can get a good test of what's going on. Now, interestingly, when I open the gate, you can see a slight thaw at the bottom of the heat pump, but then it goes into defrost mode. So once the heat pump's gone into defrost mode, I go around and check the thermometers. So here at the front of the heat pump, it's 0.5 degrees. Interestingly, I tested it a couple of days ago when the ambient temperature was lower, and this particular temperature was -2. This is another thermometer I've got a little bit further away from the heat pump, and that's just monitoring the ambient air temperature, which seems to have dropped a little bit. Here you can see that the temperature of the air entering the heat pump is approximately 2 degrees. The temperature on top of the heat pump is 6 degrees. And once again at the front of the heat pump it's minus 0.02 degrees. So here I'm going to use a smoke pellet so I can get a good visual indication of what's happening with the air as it exits the heat pump. Here you can see the smoke hitting the fence, and it is going up, but I think that's because it's slightly warmer than the other air because it's heated obviously via the smoke pellet, so it's got a bit more buoyancy. Now the smoke is just hanging around because it's cooled down and it's lost all its buoyancy, and I can see that it's swirling in the background there. Clearly this situation is not acceptable as the heat pump is recirculating previously processed air, and so it's really affecting the efficiency of the heat pump. To rectify this problem, I think we've only got two options at best. The first option would be to remove the gate and see if that affects the flow of air around the heat pump. The second option would be to relocate the heat pump. Fitting the heat pump at high level on a bracket is not an option, as there are potential issues with the neighbour and planning. So that's it, 2 steps forward, 1 step back. If you've watched this video to the end, I thank you for your patience. If anybody watching has got a solution or a suggestion about this situation, please leave it in the comments below. Thank you. And I thank you for your subscription. Thank you.